Hello, today we're going to be talking about adding and subtracting expressions with rational exponents, and also that includes radicals that are not just a regular square root. So first let's talk about a few that are just regular square roots. So if we have 3 root 5 plus 4 root 5, we need to make sure that we always have the same radical. And since we have root 5 on both, then we can just do the math with the numbers out in front. So 3 plus 4 is 7, and we keep the square root of 5 underneath. And we can't do any simplifying with the square root of 5. So we will just have 7 root 5. With this, we have root 8 and root 8. We can simplify root 8 first, but I would suggest combining into one radical first so we can do the math with the numbers out in front. So minus 7 root 8, and then we can simplify root 8 by taking a 4 or a root 4 out, which is going to be 2. So we have minus 14 root 2 left over. For the next one, we can't add first, so we need to simplify. So the square root of 27 would be 3 root 3. And that 3 on the outside is going to multiply with 2 to be 6 root 3. Same with root 12. That's a 4 times 3, so that's 2 is going to go to the outside, so we get minus 8 root 3. And then now we can add those because we have the same radical. And so we're going to have minus 2 root 3 as our final answer. In this next one, we see that we have 5 and 5. However, we also have a third root as our index, and so we cannot combine those two because they are not the same root. And so that brings us into working with radicals that are not just square roots, but everything that we add, the root has to be exactly the same if we are able to add those using the same rules that we have done before. So root 5, the fifth root of 7 and the fifth root of 7 are the same, so we can just do the math with the numbers out in front to say 5 times the fifth root of 7. And we can't take the fifth root of 7, or we can't simplify that any further, so that would be our final answer. For the next one, we have the cube root 54 and the cube root of 16. Those aren't perfect cubes, and they're not the same, so we have to do some simplifying. So we should see that 54 is really 27 times 2. And so the cube root of 27 is going to be 3, and that's going to join on the outside. So what we're saying is 2 times the cube root of 27 times 2. And then we can say the cube root of 27 times the cube root of 2. This is just going to be 2 times 3 times the cube root of 2, which is going to be 6 cube root 2. The same thing can be said with this. We're just going to have minus, 16 is not a perfect cube, but 8 is a perfect cube, and 8 goes into that. So we would say 8 times 2. We would have the cube root of 8 times the cube root of 2, and that's going to be minus 2 cube roots of 2. And so then we can do the math now with 4 cube roots of 2, and that would be our final answer. So we do have to do some simplifying. But it follows similar rules as just a regular square root. We're just now dealing with cube roots. When we move to exponents, so we just need to have the same exact, if we want to add two pieces, the base and the exponent have to be the same. So if we have x to the 1/2, we're going to keep x to the 1/2, and then we would just say 3 plus 4 is 7. If you want to think about it, this is really just saying like 3 times the square root of x plus 4 times the square root of x, which we would always just say keep the square root of x, which is our x to the 1/2. And then 3 plus 4 is 7, and then you can convert that back into an exponent. But it's much easier just to know that the same base raised to the same exponent. You can just do the math of the numbers and keep the base and the exponent the same. So same thing here. We have a to the 4/3 and a to the 4/3, so we can just say 5 minus 7 is minus 2, a to the 4/3. So you do not have to convert to the radicals. You can automatically get there, and this should have been our answer on that one. Same thing is true when you have multiple pieces or multiple bases. So if you have the same thing here, then as you do here, then you are able to just keep those the same and do the math of the numbers out in front. So we would have a positive 8. We can't do any simplifying, so that would be our final answer. Similar problem, we have a to the 6/5 and a to the 6/5, so we can just say minus a to the 6/5. If you want to say minus 1, you can do that as well. Lastly, if you have a numerical base, same kind of properties, because we could convert this to a radical if you want, but as we talked about earlier, we do not need to know that this is the exact same as this. So we can just do the math with the numbers on the coefficients out front. So 4 plus 2 is 6 times 3 to the 1/4. We also need to be thinking in our heads, can we take the 4th root of 3, which 3 is a prime number, so we know that that's not possible. So this would be our final answer. So we do need to be checking. If that was like a 16 or something like that, we would need to simplify that because we can take the 4th root of 16. Same thing here, we have 2 to the 2/3 and 2 to the 2/3. So we can keep 2 to the 2/3 and then just do the math with the numbers out in front. So we have 5 minus 11, which is going to be minus 6. And again, we cannot, looking inside 2 and the cube root of 2, we cannot take the cube root of 2 because 2 is prime. So we have that as our final answer. So you should be always checking those to make sure. So if we had like 8 to the 2/3, you would need to simplify that to 2 and then square 2 to be 4. So I hope this helps with adding and subtracting expressions that are either non-square roots or they are exponents with rational exponents.